Today we are going to continue talking about the graphs of sine and cosine, and we in our last lesson talked about the y-axis, what's going on there with our amplitude and our midline. Today we are going to take a look at what's going on in the x direction, and we are going to talk about the period of the graph, or the length of time that it takes for it to go through its whole set of points. So let's say that you're given a graph that looks something like this, and you are asked to find the period of the graph. Okay, so sine and cosine, if you're actually just looking at a picture of them like this, we wouldn't know whether this was actually a sine graph or a cosine graph because they go through the same wave pattern. It's just a matter of sine, when it hasn't been shifted, starts at the origin, and cosine, when it hasn't been shifted, starts in the up position. But once you start bumping them over, then who's to say which one it is? And this one has been shifted because our y-axis intercept right here is not a midline value, and it's not a high value or low value. So we don't know whether this would be a sine or a cosine. It actually doesn't matter if what we're trying to find out is the period of the graph. So to find the period of the graph is the amount of time that it takes to go from a matching point to a matching point. So it could be a high value to the high value. It could be from a low value to a low value. Or it could be from a midline to not the next midline, because if I cut off just that part of the graph right here to here, I don't get the whole cycle then. I only get a low part. I need to include a high. So it could be from middle to the second middle so that I get the full middle down, middle up, middle. Okay, that I have both an up and a down covered within there. So it could be from a middle to skip a middle, next middle. Okay. Now the nice thing about sine and cosine is that it is completely symmetrical in how it goes through these points. It takes the same amount of time to go from a high to a middle as a middle to a low to a middle to a high to a middle. Each of those take exactly the same amount of x distance. So that means that we can, there's still the work from the last lesson there, so go ahead and erase that. We can, as we think about a graph of either sine or cosine, say that this full length is the period of the graph from beginning to end. And if we break it down into each of those, there are 4 sections of the graph then. Section 1, 2, 3, and 4. So in the problems, you might be given a high point and a low point. Well, how much of the graph should be covered within a high point and a low point? 2 sections, or half of the period should be covered there. So what we would want to do is then take the x distance between that, and if that's half of the full thing, then we would need to double to get the full length of the period. Or you might be given, let's say, a midline value and a low value. Well, that's 1 section, so if I want to know how long is the whole period of the graph, I would need to multiply by 4. Okay, so I kind of tried to write these up as some like general rules for you. So let's see. We'll say that the period is equal to 2 times the x distance between, shorthand there, BTW, between high and low. Okay, so if we have our distance between our high and our low, that's what I drew there in purple, we would need to double that to get the full period length. Or another option would be that it is 2 times the x distance between two, we'll say, adjacent mids. Okay, well, what do I mean by adjacent mids? Well, adjacent means next to each other, and then I mean next to each other middle values. So here, I'll start with that first one, and then here's a second middle value. Well, that covers 2 sections. Or if I did the other 2 mid values, then that would cover 2 sections. Now, I mean adjacent, because if I skipped the mid and did like the first mid and the last mid, well, then that's actually the whole period. Okay, but I don't think any of the problems give you that, but that would actually then be the whole period. So if we have 2 adjacent mid values, that would cover half of our graph. So then we would need to double it to find the period. Or we could also do 4 times the x distance between a mid and high or low. Okay, and that is what's in red there, that if we have a mid and either a high or a low, that only covers 1 section, so then we would need to multiply by 4. Okay, so this graph is a little ugly. As I look at here, I'll grab, here's a high and here's a low. We got some really messy decimals there. But what I'm going to want to do is subtract them. So I actually did grab a calculator. So as I find the x, so today we're talking about the x, not the y's. The y's are actually nice clean numbers here, but we're talking about the x's. So as I look at those x's, I'm going to do 3.427 minus 1.856. Okay, that tells me the difference between those 2 x values, and I got 1.571, which actually, because I'm kind of familiar with numbers, I guess, being a math teacher, that actually is a half of pi. If pi is 3.14, a little bit more than 3, and you cut that in half, 1.57, that's actually a half of pi. But anyway, so that is between a high and a low. So as we think back to this, if I have a high and a low, that's the purple. That covers half the distance. So I need to double that if I want to find the period. So I double it, and it says 3.142, which is actually pi. So the period of this graph is pi. That means to go from one high point to the next high point, there's a distance of pi between those. Or to go from a low point to the next low point, distance of pi between those. Or from a middle to not the next middle, but the next middle, there'd be a distance of pi between those, right? So that is how you can find it from a graph. We'll look at one more. Let's say, we'll just leave that. Okay, so on this one, let's say that I was given this middle value and this high value. Okay, well, it actually gave them to me in fractions there. So if I want to find the period of this graph, if I'm working with a middle and a high, that is like this one, it's only 1/4 of the full graph. So I'm going to need to find the distance between those, and I'm going to need to multiply by 4. None of the problems that I saw in Khan Academy have fractions. They're all decimals, but we'll go ahead and just work it through with the fractions. It's good, good review. So let's take the difference between those. So pi halves minus pi thirds. Okay, well, when we add or subtract fractions, what do we need? Common denominators. So I'm going to turn those both into 6s. which means 3 pi over 6. 3 over 6 is 1/2, so that's still equivalent. And the other one, 2 pi over 6. 2 over 6 is 1/3, so that's still equivalent. And when I subtract those, I get pi over 6. Okay, so that one section has a length of pi over 6. But because this is the mid and a high or a low, there's 4 of those sections. So I need to then multiply by 4. And I get 4 pi over 6, which I could reduce to 2 pi over 3. Oops, that just fell off the screen there. 2 pi. Well, not off the screen, but it fell behind me. Okay, 2 pi over 3. Okay, so that is how we could find them from a graph. Okay, how can we find them from an equation? So when we were talking about amplitude and midline, the numbers were like, well, they were like right there in the equation. We got our amplitude up front. We had that midline in the back. The period is also in here, but it's not quite as just like there. We have a little calculation to do, but it has to do with this number right here. It has to do with the number that we're multiplying by the x. That number is what changes the pace of this repetition of the curve. So as I plug in a big number here, let's say 10, it's going really, really fast. An application of these is actually, we could think of sound waves. We could actually model sound waves through trig equations. And this has a very high, what we call frequency, which would mean it's like a high-pitched noise. If I put in a small number here, like let's say 0.2, whoa, I can hardly even see the curve happening here. It's really stretched out. So in music, this would have a very low frequency. It would be a very low note, right? The amplitude would actually give us volume. So as we make it taller, it'd be a louder note, either high or low pitched, depending on the length of the curve. So little application there as well. But how can we find the period from the equation? It has to do with this number that's right here. Now let's say the first problem we did was there was a 3 there, so we'll go ahead and put that 3 back, and the answer we got was 2 pi over 3. That is the general rule. 2 pi divided by this number right here that's multiplied with the x. 2 pi divided by, we call that the b value. 2 pi divided by the b value. Okay, so I'm going to, let's see, I'll erase the work we did on that problem, and I'm going to write up for you our general trig equation is going to be y equals, we say a, and then either sine or cosine, so I'm just going to say trig. It's actually different for tangent. So it wouldn't work with a tangent here. Tangent behaves a little bit differently. As we saw, it was like the straight up and down things. So here, this is only sine or cosine. And then it's going to be of, I'm going to say bx plus c, and then plus d out here. So we already learned in the last lesson that a is our amplitude, and we learned that d is our midline. Right? Now in this lesson, we're going to say that our period is equal to 2 pi divided by b. 2 pi divided by b gives us that midline. What that c value would do would actually take the graph and move it over sideways to the left or to the right. So that would create a horizontal shift, but it's actually going to shift it by c divided by b is how much of a shift we're going to have there. So just like it's 2 pi divided by b, our sideways shift would be c divided by b. But we're not going to worry about that. That's called a phase shift. So that's just a little something so that you know what that c value does, but you won't have any problems asking you about that c value. So you're going to look at the period of the graph either by being given 2 points on the graph, maybe that only cover a quarter of the graph, maybe that cover a half of the graph, and then do your multiplication. Or from an equation, you're going to look for this number that's multiplied with the x, and the period is 2 pi divided by that number. Okay, Let me know what questions you have as you're working on your assignments, and I'll see you again soon. Have a good day.